Lesson 4 is about the scenario, but more about interpreting the units that are used in the scenario that we've been graphing from lessons 1, 2, and 3. So we talk about units of formulas, and the goal of this is directly tied to a standard, directly tied to a smarter balanced item. And it is going to be emphasized in this lesson with the intention that from this point on, whenever you see some sort of context or a scenario that requires you to interpret the surrounding information, that you think about the units of measurement that are important. Many of the examples will actually come down to, are you appropriately using miles per hour or something in that nature? Let's do the entry task together. It's really just about identifying, like, what do you understand, like, what we mean by a unit of measurement? Good Google word. Let's actually deviate for a second. Unit of measurement. A unit of measurement is loading. A definite magnitude of a quantity defined and adopted by convention or by law. Okay. It's a measurement that we talk about in units. It's any measurement. There's one of them. So a meter is a unit. 1 meter. 1 second is also a unit. I guess that's what we're doing. In here, it says distance traveled for a road trip. Miles. Or if you're in Canada or elsewhere in the world where we are more sensibly scientific, we could say kilometers. Wobbly table. Okay, let's go to the next one. Number 2, the speed that a person can run. It really doesn't make a lot of sense to say that a person can run in miles per hour. But that is something that is a unit of measurement that we are familiar with. Certainly if you're driving or if you're about to start driving, you understand that miles per hour is the speed limit. And it's written as mph. It literally means that you will travel that many miles if you have been driving for 1 hour. Maybe a better way, if you're thinking like in a race, 100 meters in 11 seconds, you can run 100 meters in 11 seconds, and that can reduce down to a unit of measurement of how many meters per 1 second that you can run. So meters per second. That's another way to write it. Using the fraction, because it's a rate, because of the word per, we want to think about that as a fraction. So that's why I wrote meters on top and seconds on the bottom. Next up is how much water an athlete drinks a day. And we could say this in gallons, or we could say this in quarts, or we could say this in liters. Gallons, quarts, or liters. What doesn't make sense is to use something that's one like a weight, like kilograms, or it doesn't make sense for us to say like, milliliters. Like that's not an option. That's too small. I drank 1,000 milliliters. No, you drank a liter. Okay, the amount a person earns during a week at work. So amount earned is a dollar amount, some monetary unit. And the fact that we use the word during, that's like the use of the word per. So the amount of money earned per week. And this whole thing is considered a unit of measurement because of the scenario of money made during a week. We have to take care of both of those. We're going to see those types of ideas, the fact that you need to identify all of the possible parts to the word problem. So in the classwork, so we're going to see like all the different things you need to identify. Here we go. Question 1. Students love to put ranch dressing on everything, so Elvira needs to keep plenty in stock. The students eat about 2.25 gallons of ranch each day. Elvira started the school year with 130 gallons of ranch dressing, and she needs to have at least 20 gallons left when she reorders to have enough in stock until the new order comes. So the question, for how many days will her ranch dressing supply last before she needs to reorder? Great question. Great math question. Probably a division problem. But when it says describe in words the units that would work in this situation, this is where we start looking at the words that are associated with every number. So 2.25 gallons of ranch each day. So gallons per day. That's a unit of measurement that you need to know about. And because it's written like this, I'm teasing that number out of the problem. Day and gallon are also units of measurement. Day, gallon. And there's even one more that I could acknowledge, that maybe it's as a collective, it's her students, the entire students of the high school or of the school building. But to a degree, students is a unit of measurement. And maybe it'll even come up in further problems. So let's go to question 2. Elvira can purchase ready-made pizzas for $14.50 each. If she makes them in the cafeteria, she can spend $44.20 on ingredients and $6.25 per pizza on labor. For how many pizzas is it cheaper for the cafeteria to make the pizzas themselves rather than to buy them ready-made? Okay, great math question. Would love if you felt like you needed to take the time to answer that and figure out which is better and what's the scenario for when one is better than the other. But all I'm interested in this one is the units of measurement. So I'm going to look at the numbers first. I see in the number, I see 1450. And from the 1450, I notice that it says ready-made pizzas. So $14 per ready-made. Ready-made is not a nice, scientific type of measurement, but it's definitely something that's specified in the prompt. So I'm going to identify it in that fashion. It is a fraction, dollars per ready-made pizza. I had to make the word per work, but it does work. Next up, if she makes them in the cafeteria, she can spend $44.20 on ingredients. Money again, per ingredients. And then $25 per pizza on labor. Interesting. The on labor part means like somebody had to make it, so that's the staff in the kitchen doing the job of creating the pizzas. It's still a money amount. It's per pizza on labor. So it's the money in terms of labor per pizza. So I guess I'm putting money and labor together, and that's also to help separate these two money-wise from each other. They're not the same thing. For how many pizzas is it cheaper for the cafeteria to make themselves and buy them? So each of these, just like above, gets to be its own unit of measurement, because we don't know how we're going to use pizza and ingredient and labor and money all at the same time, or where we're going to need them. But they are the units of measurement for this problem. This question makes me hungry. Here we go, question 3. Elvira is trying to order milk for the school. She knows she needs enough milk for 2,000 students per day, but she has to buy the cartons in boxes. There are several companies that sell boxes of milk. That's a unit of measurement. So use an X to mark 2 or more quantities that, when multiplied together, would give a quantity that could be used as a single measure to decide which milk company is the cheapest for them to buy from. I think I'm just going to cross out those 2 words. Which company is the cheapest? The idea is that if you have a fraction like dollars per minute, you can multiply it with minutes per material. I should just show you. But you can multiply the fractions and top and bottom cross out. So in order to do this problem successfully, the first thing you should do is write the fraction down for each of the options. Cost per box. And then cost per carton. You know they're different, right? Like, I hope I know they're different. Yeah, she has to buy the cartons in boxes. So you get one of those milk crates, and it's got, certain containers of milk in it. So we're either buying bulk or buying single item. But these 2 fractions are comparing the cost for each. The next one, the number of boxes of milk per student. So the word per allows me to separate the first phrase or section of the sentence, the first quantity, from the second. And that per means I have a top that's definitely on top and definitely something that goes on the bottom. Something like this. Boxes per student. Kind of a weird number, though. It's like you're saying that 4 boxes per student, like one student's going to drink 4 boxes of milk. Oh my God, they're going to have a tummy ache. Okay, last of all, the number of students a box of milk will feed. Flip that. This is the exact opposite of this one. It's students per box. Okay, so in order to think about which of these two fractions we are going to combine, units of measurement that we're going to combine, we need to look at something that is the same for two fractions, but located on the top of one fraction and on the bottom of the other. Money is mentioned twice, but they're both on the top of the fraction, so these will not go together. Box is mentioned 3 times, and student is mentioned twice, but we want to say a quantity that could give a single measure to decide which company is the cheapest. Cheapest means which one's going to cost the least. So I'm either going to use this dollars per box fraction, or I'm going to use this dollars per carton fraction. It really just depends on which word shows up the most. Carton does not show up any other time, so it's out. We're going to choose dollars per box. And we're going to multiply dollars per box by a fraction. Let's see, box is on the bottom. By one of the fractions that has box on the top. This one does. Boxes per student. The truth is, when you take just the units of measurement, like box on bottom, box on top, these cross each other out, and we're left with something that does actually make a lot of sense. The amount of money per student. You want to think about that when you run a business. What is the unit cost of the item that you're producing and selling? If it's a high dollar item, then you got to think about, okay, what's it going to cost to make it? And this is the same thing that's happening. So it looks like this option, oh wait, use an X. This option and this one. Okay, that's absolutely a skill you're going to need to know for an upcoming assessment, a stressful setting. But the strategy is to take the phrase and turn it into a fraction, and then find 2 fractions, bring them together, find 2 fractions where there is a quantity on the top and a quantity on the bottom that will cross out. I'll try number 4. You try number 4 by yourself. A homeowner is looking into the cost of installing new flooring in their home. The area they want to get new floors for is 640 square feet. Each case of different brands of flooring covering different area square footages. Choose 2 or more quantities that when multiplied together would give a quantity that could be used as a single measure to decide which brand of flooring would be the least expensive. Hey, there's a money amount for them to use. So because of the idea of least expensive or cheapest, there has to be a dollar amount in your problem. And as a reminder, I'll do this on a couple of these. Your first step for this problem should be to write the fractions. No numbers, but the fractions where you look for the word per or each or during or when. Something that says like this quantity is separate from this quantity and the one goes on top and the other goes on the bottom. Let's do the first one. The number of square feet a case can cover. So the number of square feet per case. I write that fraction down. I'm going to do it for all 5. You should do it for all 5. The number of square feet a case can cover. I'm going to write square feet per case. The cost per case. I mean, it's told to you right there. The cost, per can of case. I think this is a typo. Get rid of that. The cost per case. So the cost per case. These 2 fractions both have case in them, but they're both on the bottom, so they're not going to cancel each other out. You're looking for something that will cancel. And least expensive means that money, hey, ding, ding, money needs to be considered. Okay, continue writing out the fractions, and then look for fraction pairs that you can use to cross off and be left with money over square foot. I don't know. I'm going to go ahead and answer this. So give me a minute. Skip ahead when you're done, when you're ready. Pause. Okay. So I noticed from this one that the fraction's cost per case and the number of cases will be multiplied together, because that's what you do. And case will cross out, leaving you with dollars per square foot. I also noticed that dollars per square foot was one of the options, but we're leaving that one out for right now. I mean, like it said, multiply together, right? You have to do that problem right there. Dollars per square foot is the best. That's what you're going to do when you go to the store. You cross-reference how much money it's going to cost for this unit measurement of one thing. And you compare it to the other unit measurement of one thing, and together you know which one's cheaper, so therefore beneficial to buy. But if you have to multiply two things together, it's a chemistry property, then you look for something on top and bottom of the fraction that can cancel out. Yeah, let's go through the notes. When given a formula and you're asked to determine the units, you can simply just substitute the given units into the formula to give you the units of the answer. For example, F equals MA, and M is kilograms, and A is meters per second squared. Then we just plug them in. Plug them in. And we get kilograms times meters per second squared. And that's totally fine. That's how you do it. That's the homework idea. Should we try one? Turn the page. Ah, not that page. Get out of here. Okay. Here's a good one. I love this one. This one's going to show up so many times, you're going to get sick of it. Not that you wanted to know that, but it's just what's going to happen. The kinetic energy formula, it is K equals 1/2 mv squared, where K is kinetic energy, M is mass in kilograms, and V is velocity in meters per second. The units of kinetic energy is literally take kilograms, put it there, meters per second, put it there. Done. Almost. Done. I want to distribute the exponent though. You know, the 2 goes to the M, goes to the S. So that's why both of those are squared. The 2 does not go to kilograms. So there is no squared right there. That would work. Let's try the next one. The formula for energy, you know, Einstein's formula, is given by E equals mc squared. E is energy, M is mass in kilograms, C is the speed of light measured in meters per second squared. Hint. We're going to take kilograms because it's mass, and we're going to put that in the formula. We're going to take meters per second, and we're going to replace C because C is squared. Now that's not quite the answer, but that will work. We're going to go ahead and say that square the meters, square the seconds, kilograms, meters squared over seconds squared. This is our units of measurement for energy. Energy are these 3 quantities in exactly this arrangement. Okay, I want you to do number 7. The formula for frequency is given by frequency equals speed of light measured in meters per second divided by wavelength measured in nanometers. nm, nanometers. So determine the units of frequency using the formula. Pause. I'm going to answer it. Come back in like 30 seconds or skip 30 seconds ahead and see what I write down. See if you agree. You might have got this, and you'd be right. But I don't like to leave things, you know, fraction over fraction. That's bad math. So I'm going to put the nanometers over 1, just a space holder, and then I'm going to flip and multiply. I'm going to try to cancel out the denominator. So 1 over nm, 1 over nm, those cancel, and I'm left with meters and seconds times nanometers, which is that answer there. That's the units of measurement for frequency. All right. On the back, closing, Please make sure that you read through the success criteria, give yourself a rating, let's say 0 to 5, and how can you improve? Like I said, I've been doing before. How could you improve to the point where you could teach it to someone else? And then on the last one, a farmer is comparing costs for different fertilizers. Recommendation is that you write out all 5 fractions and then look for least expensive, meaning what costs the least amount of money. That will close out lesson 4 and close out my notes for the week. Hopefully when I come back, you can tell me that this was successful. I'm hoping it's successful. I'm trying to make it be successful. But it depends on how much use you get out of it and if it was worth your time. The problem set is homework. Any other question that we didn't cover is homework. That goes for everything from lessons 1 through 4. If I have anything else for you to do, it'll be posted to Google Classroom, so please be checking on that. And if you don't know how to get there and you're watching this in front of the class, someone in the room should know how to do it. So don't get stuck, left behind. Figure it out, figure your life out, and ask for help. Okay, bye.